Most of us buy our fruit and vegetables without having much idea as to where they come from or how they grow. Fruit and vegetables you see here and in the shops don't give you much idea of the whole plant, what they look like when they're actually growing. Take this corn on the cob, for instance. Have you seen this growing?
These are corn on the cob plants, and all these leaves and stems help to provide food for one or perhaps two cobs on each plant. We never eat the rest of the plants, just these juicy yellow seeds on the cob. But there are some vegetables that we do eat nearly all of. We eat all the leaves of the lettuce, and if the slugs don't get there first, all of the cabbage leaves. But did you know that Brussels sprouts grow like this? The little buds growing on the stems are the part of this plant that we eat. This forest of green is hiding another vegetable you recognize. In this case, we eat the stems. It's celery. This is the main carrot plot here at Wisley, but there's not a carrot in sight. The carrot, as you know it, is under the ground. Here's another very common plant. You don't eat the leaves of this either. You have to be very careful when you dig it up, or the fork goes right through the parts you're after. You get more than one helping of chips from this plant. Under these leaves, there's another vegetable, not as popular as the potato, but it's very good mashed up with gravy. It's a swede. Swedes, carrots, potatoes and celery. Just a few of the vegetables we buy at the greengrocer's. There's no point in carrying to the market the parts of the plant we don't need, so usually only the parts we eat find their way to the shops.
The fruits and vegetables we eat today haven't always looked as they do now. Take carrots, for instance. That's the modern carrot on the left, and on the right, the wild variety it was bred from. On the left, the modern cabbage and the wild variety. Potatoes have changed a lot, and so have apples. Growers and scientists work together to improve lots of wild fruits and vegetables to produce the varieties that we like to eat. These delicate red flowers are actually one kind of wild pineapple. Each flower grows into a small fruit, growing individually like a grape. And it's from wild pineapples that scientific plant breeders have produced the pineapple that we know today. In the fields, the modern pineapple is grown not from a seed, but from the bunch of small leaves at the bottom of the plant. It's called a slip. It would take a long time to plant hundreds and thousands of slips by hand, so engineers have designed a machine which plants the slips mechanically. A metal arm on each side gently picks up a slip, swings downwards, punches a hole, and plants the slip. When you look at the size of a pineapple field, you can see why developing a planting machine was so important.
Looking down on the plant, this is what it looks like about 17 months after planting. That spot of red in the middle of the leaves is the developing flower, made up of about 130 tiny buds clustered together. 1 month later, the small cluster shows the first sign of becoming cone-shaped. Slowly the cluster gets larger until the mass of red buds begin to blossom. For one brief day, the flowers are beautiful. Then the petals wither and the rest of the flower becomes part of the slowly developing fruit. If you cut through a plant about 18 months after planting, this is what it looks like. The base of each flower is joining up with all the others to produce one big, juicy fruit.
2 years after planting, the pineapple's ready to be picked. From the fields, the pineapples are taken to the cannery. Here, the fruits are thoroughly washed and sorted out into different sizes. They then move one at a time onto a conveyor, which carries them to the coring machine. Metal fingers place the fruits in exactly the right position, and a sharp, spinning, circular knife rapidly cuts away the skin. When you look at that in slow motion, you can see how neat it is. Each pineapple is pushed onto the blade by the one behind it. Now they're sliced. A set of sharp knives cuts the pineapple into rings, ready for canning. Finally, syrup is added, and the cans go to be sealed and labelled.
Off with the gas. Be with you in a moment. Now, be careful here. It's boiling hot. Another can of favourite food, baked beans. And what would we do without them? We eat 400,000 tons of baked beans in tomato sauce every year. That's 4.5 million tins every day. And all of them come from Michigan in the United States of America. We don't grow any of our own. To find out why, our guest this week is Richard Hardwick, and he's from the National Vegetable Research Station in Wellesbourne. Hello, Richard.
Hello, David.
So why is it we don't grow our own baked beans?
Well, of course, some beans will grow very well in this country. Here's an example of a bean that we got from the mountains of Central America. This is a cold-tolerant bean. We bring it to this country, and it grows very well. But this is a bean which we got from North America. This is the one which they use for canning as baked beans. When we grow it in this country, you can see that the plants are small and yellow and stunted. This is because, we think it's because, they're growing at a low temperature. They're not happy, and when we get to harvest, it won't be a very good yield. This is not a variety which grows well in this country. I can show you a bit more of what I mean if we go and look at some that are growing better than this in a glass house. Here you can see the American bean growing in the glass house and almost ready to harvest. Now, the problem is this: it's small and stunted and not growing very well, so the pods are close to the ground, and where they touch the ground, they rot. What we would like for the farmer is a bean that grows like this, with pods well off the ground and a lot of them, so that when he comes to harvest them, they're not rotting, and he's able to get his combine harvester through the field and cut off the plants and get a good yield of beans for baked beans.
I see. So why don't we use those plants for our baked beans?
Well, let's have a look. If we open up a pod and look at the seeds, well, these seeds are all black. They're not going to be any good for baked beans. What we want for a baked bean is a plant that has seeds that are white. Have a look at these. This is a collection of beans that we've got from all around the world. Some of them are cold tolerant, but the seeds aren't the right colour. They're not white. Instead, they're grey or brown or black, or they're long or they're spotted. The only one that's any good is this one at the bottom. This is the haricot bean, the white bean, which we've seen growing in the field was no good because it's not cold tolerant. So that's the problem. The ones that are cold tolerant have got seeds that are the wrong colour.
So what you're looking for, Richard, is a plant that will grow well in our colder climate and will have white beans, hmm?
That's right, David. What we've done is to grow lots and lots of different beans outside in the field. And we measured the rate of growth of their leaves. That experiment shows us the most cold-tolerant bean, the bean that grows best at low temperatures. And its seeds look like this. And we've crossed this cold-tolerant but black-seeded variety together with the white American bean. And the offspring of the cross between those two varieties has seeds which look like this. A mixture of seeds of all different shapes and colours, and of course, not all of them will be cold-tolerant. So we grow them in the field and we measure their growth and we select the ones that are cold-tolerant and have white seeds. And we have to do that for 6 or 7 generations. Now, the result of our work is here. This is the first can of beans made from a British baked bean grown and bred in England.
If Richard's beans are going to be successful, they've got to taste right. And to find out whether they do, Malcolm's been to Chipping Campden.
Well, I've come to a food research laboratory to ask the panel of baked bean experts if they'll compare Richard's British baked bean with the North American bean from Michigan. In the kitchens, the cans have been pierced and boiled. Now, so the panel don't know which beans are which, the cans are number-coded. But we know that Richard's beans are in can number 2. Right, there we are then. Off you go. The colour, appearance and flavour of the beans are checked by the panel, giving marks out of 20 for each. If Richard's are as good as the Michigan ones, he's well on his way to a successful British baked bean. Now, Beverly, you're testing for flavour.
Yes.
Would you like to have a taste of number 1? See what you think. That's obviously not very nice, is it?
No, it isn't. It's got a funny off-flavour present. I think I'd score that 11 out of 20.
11?
Yes,
Not very high
not very
at all.
nice.
Well, that's number 1. Would you like to try number 2? You look happier with that?
It is a bit better. A little bit weak, lacking tomato flavour. But it's about average.
How would you score it then?
About 14 out of 20.
Well, that's a good score. So Richard's beans are well ahead on flavour. Now, what about colour and appearance?
A perfect bean will have a very bright, attractive appearance. The beans will be not too pale or not too dark. There will be no off colours, no grey tints, no brown tints.
There wasn't much to choose between the beans on colour and appearance. Both had a number of grey and brown tints. The Michigan bean scored 12 and Richard's bean 13. In the end, the difference was in the flavour.
Number 1 really is a substandard product because of the flavour. Number 2 is fairly average baked bean.
Well, that's rather good news for Richard because number 2 is the great British baked bean.
That's splendid. And what's still to be done, Richard?
Well, David, we have to check our results out. So the variety of bean that we bred at England, at Wellesbourne, is being tested on farms across England this year and next. And if all goes well, then in a couple of years' time, we hope that we will be able to release to British farmers seeds of a variety which has been bred for cold tolerance and disease resistance, and that will grow well in England and give us British baked beans.
And the best of British luck.
Thank you, David.
While Malcolm's been taste testing, Lillian's been to Staverton to see how baked beans are canned.
When they arrive in the canning factory at the end of their journey from Michigan, the first thing that happens is the beans are checked. A sample of beans is taken from a number of sacks using a special spike sampler. The beans run from the sacks and are mixed together in the plastic bag and then taken to the laboratory to be examined. In the laboratory, 500 grams of the beans are weighed out from the bag, and are separated into good beans and rejects. These are the good beans, 490 grams of them. The rejects divide into those with split coats, those broken in half, those of the wrong colour. There's an occasional lump of soil and the odd stone. The laboratory check is important as it lets the people in the factory know what to expect when the beans are sorted. First, the beans are sorted for size. Beans that are too big, some stones and other bits and pieces which can't pass through the holes are rejected. This machine sorts out the beans that are the wrong colour. An electronic eye scans the beans, and any bean that's not white is blown out of the way. The good beans may still contain some stones, and to get rid of them, the lighter beans are lifted on a current of air and the heavier stones drop out at the bottom. Now the beans are carefully washed, then heated in water to about 90 degrees centigrade. It's called blanching. After the beans have been blanched, they go off to be canned. This is the canning machine. A fixed amount of beans is pushed into each hole and then dropped into the cans. Then the cans are topped up with tomato sauce before the lids are sealed on. The beans are cooked in the can inside these ovens, and at different times of the day, cans are collected to be tested the next morning. The testers are not only interested in the taste, but also in the colour and appearance of the beans. Everything has to be right, and everything has to be recorded. The letter N means normal, and each sample is checked for flavour, colour and appearance. Only one sample, the 10 past 10, didn't come up to the tester's very high standards. It was just a trace too pale. Testing is very important, as it makes sure that when the label is on the can, you can rely on the quality of the 400,000 tonnes of beans we all help to eat each year.
Do you want some spaghetti, Lillian?
Spaghetti? I thought this programme was about fruit and vegetables.
Ah, well, it is. This is a vegetable. It's a spaghetti plant. It's a kind of marrow, actually.
Oh, what are you going to do with it?
Cook it.
Well, how long does it take?
Oh, about half an hour.
Half an hour?
Yeah. Like all good cookery programmes, I've got one ready. Yeah. You can see now why it's called a spaghetti plant. There you go. You want some spaghetti, David?
No, I won't bother, thanks, Malcolm. I've got my eggplant here.
Eggplant?